Good evening, class. As I told you, I'd make a screencast about some word problems involving absolute value inequalities. I'm going to make this short and sweet, and all I want you to do is listen to these screencasts, and then we'll talk about them tomorrow in class, and we'll go over some problems involving them. All right, let's take a look at some absolute value word problems. It says, a recent poll shows that candidate Ali Ekmi would win 46% of the vote with a margin of error of plus or minus 3%. I think we've seen this in the past. This is really common for news agencies to describe a candidate's how popular they are using this kind of numbers. So what I want to do is I want to write an absolute value inequality representing this range of percentages. All right, so I'm going to start by taking a look at this. Well, it says, I know that this person would win, it says 46% of the vote with a plus minus of 3%. So on a number line, if I put 46% here, well, this person could be exactly 46%, or the poll could actually be wrong up to a number 3% greater, so 49%. They could also be 3% lower than 46%, so down to a low of 43%. So what this says is the actual candidate's vote would be anywhere from 43 all the way up to 49, including both 43 and 49. Well, again, using the idea of the absolute value being the difference between any two numbers where I don't care who's larger, I'm going to use that to represent this candidate's vote. If I say, okay, I'm going to let X equal the actual vote percent, right? If I know how to spell percent. Then what that would say is, if I had this little point representing the actual percentage, I know that it would have to be somewhere in this range from 43 to 49. Okay? Well, again, I guarantee you that if I subtracted the actual vote minus the middle value, which in this case is 46, if I found the difference between the actual vote and this 46 number, I guarantee you that X minus 46, that difference, where I don't care who's larger, would have to be less than or equal to, well, what's the maximum distance from 46 to 49? It's 3%. What's the maximum distance going back from 46 back to 43? Well, 3%. I guarantee you that if I took the actual voter percent minus this middle 46%, it would have to be less than 3%. And I hope that makes sense. Okay? So this is a way of representing this problem using an absolute value inequality. Let's look at another one. This one says, recently, a report stated that anyone under the age of 5 or over the age of 50 should get a flu shot. Write an absolute value inequality representing this scenario. Well, again, just to make it easier on my eyes, I'm going to draw a little number line. Let's see, the two numbers I'm considering are 5 and 50, correct? Now, how does this work? It says under the age of 5. So that would be starting at 5 and going to the left of 5 this way, correct? All right? And over the age of 50, well, that would be here and going this way. Now, notice that it says under the age of 5. Well, should that include 5? In other words, should I color in the 5? Huh? I don't think so. Likewise, I shouldn't color in the 50. Well, now again, if I want to write an absolute value inequality representing this, the first thing I'm going to do is going to define a variable x, where x equals the age needing, say, the flu shot, right? So what that means is, if I have a person X whose age is going to need a flu shot, that person's age would have to be in this shaded region or in this shaded region. Well, again, to represent this using an absolute value, I want to talk about the difference between this actual age and some other number. Well, what I'm going to do is I'm going to find the middle number that's halfway between 5 and 50. In other words, the average of 5 and 50. So the first thing I'm going to do is find the average of 50 and 5. right? Isn't that how you find the average of two numbers? So you get a little bit of 55 over 2, which when you divide that, I think that would be what, a little bit of 27.5, right? So I'm going to say that 27.5 is my middle number. Now just to check, how far is it from 27.5 to 50? Let's see here. I believe that's, what is that, 22.5 spaces away? How far is it from 27.5 back to 5? Well, again, I think that's 22.5, right? So, if I wanted to represent the ages that need the shot as an absolute value, then what I'm going to do is I'm going to take this age that I'm considering, x, and I'm going to find the difference between him and that middle number, which would be 27.5. I guarantee you that if I found the difference between x and this middle value, that difference would have to be, well, let's see, to get from this middle out just out to 50, that's 22.5. Wouldn't it have to be greater than 22.5 on the right and greater than 22.5 on the left? So I guarantee you that the difference between any age that needs the flu shot and this 27.5 would have to be greater than 22.5 years old, right? Or years, I should say, right? Now, it's not going to be inclusive because the 50 and the 5 are inclusive, right? And that's how you can use absolute value inequalities to represent word problems. That's enough for today. We'll talk about this more tomorrow in class. See you then.